Lesson 2.7, solving equations with rational numbers. Reminder, we've been working with rational numbers here this entire unit here in Chapter 2. Rational numbers are any number that can be written as a fraction. Remember, as a decimal, they would look like a terminating decimal, so decimals that stop, such as 0.5, because you can write it as a fraction, which would be 1/2. And repeating decimals are also fractions, because a repeating decimal can be written as a fraction. 0.6 would be 2/3. So a little crash course there on rational numbers. Today we'll solve equations with rational numbers. So you would use your same 3 steps back with solving equations with decimals. So if you actually look back, you already have the steps written down in your guided notes. First step would be to combine like terms. Second step would be to get rid of any addition or subtraction. And third step would be to get rid of any multiplication or division. This first problem here, we're working with decimals. Rational numbers, because these terminate here. So we need to get g alone. In order to get g alone, we would subtract by 2.84 from both sides. We wind up with g. 2.84s would cancel out. And we do our operation here, 3.62 take away 2.84, we get 0.78. Biggest thing today is when you go through your problem, if you are working with decimals, your answer is going to be a decimal, unless you have a whole number. So example 2, now working with equations. If it's not a whole number, we should have a fraction as our answer. So we need to get s by itself, s minus 2/3. In order to get rid of minus 2/3, we would add 2/3. So plus 2/3 to both sides. Equal sign lines up. We drop down s. Negative, and this will be the number one mistake today, right here, is not putting that negative in. This says negative 4/5. Negative 4/5 plus 2/3 is negative 2/15. So make sure that we're inputting things correctly. Example 3, negative 2/5 equals x minus 3/4. Again, we need to get x alone, so we need to add 3/4 to both sides. Equal sign lines up, x would drop down, those 3/4 would cancel out, and again, we have a negative 2/5. Negative 2/5 plus 3/4 gives us 7/20. Example 4. 7/11 c equals negative 21. In order to get c alone here, we'd actually, 7/11 is multiplying to c, so we would divide by 7/11. And again, what we do to one side, we must do to the other. Equal sign lines up, 7/11 cancel out, we get c equals negative 21 divided by 7/11 is negative 33. This is one of those where you're working with a fraction, but our answer here, we actually have a integer here, negative 33, and we don't need to write that as a fraction. 5, we have 9.7t equals negative 67.9. We'd need to get t alone. In order to get t alone, we would divide 9.7 on both sides. So our 9.7s would cancel. We're left with t equals negative 7. Last example, kind of a realistic example here. It says physics, you can determine the rate an object is traveling by dividing the distance it travels by the time it takes to cover the distance. This equation is a big one. This is one that we've already talked about this year, but it says r equals d divided by t. That is, rate is r. D is our distance, t represents time, so rate equals distance divided by time. It says if an object travels at a rate of 14.3 meters per second for 17 seconds, we want to know how far does it travel. So here's our equation, r equals d divided by t. How far does it travel is talking about a distance. So our distance is unknown. So we're solving for d. Therefore, we must know r and t. R is a rate. how fast something is. Well, here's the rate, 14.3 meters per second. So 14.3 is my rate. My time is 17 seconds, as mentioned above. Now you need to go ahead and solve for D. In order to solve for D, we'd multiply both sides by 17. And we wind up with D equals 243.1. Now, this is a paragraph here. You are solving for a distance, therefore it needs a label. And if you look up above here, our rate is talking about meters per second. So a distance is a measurement, therefore it is meters. So 243.1 meters. This concludes our lesson on 2-7, solving equations with rational numbers.